My name is Bimschas. I'm with the University of Lübeck in Germany. For those who don't know, that's at the very north of Germany at the coastline. And I am the one that used to be responsible for, is still responsible for the development of the software infrastructure. I used to work for the WiseBed project, and last year I joined the SmartSantander project. So most of the stuff that I've been doing was on the software side, implementing the back end of the the testbed architecture. I just want to give you a very short overview because our testbed is much more basic. Basically, it's a classical indoor testbed. We have seen that before today. We've heard it that there were so many indoor testbeds. We basically inherited this deployment from the WiseBed project, brought it into the Santander project, and extended it for some more nodes. So what we have is the rooms of our institute equipped with a bigger amount of sensor nodes spread all over all rooms. So here we see, let's say, most common use cases, so it's very classic use cases. Most of the time the testbed is used to evaluate protocols on all types of layers. So we have, for example, routing protocols that work directly on the MAC layer. We had lots of experiments involving implementations such as 6LoWPAN, CoAP, so on all types of layers. Our testbed was used to basically debug the implementations, evaluate the protocols, how good they achieve their job. For that purpose, the big advantage of our testbed is the wired backbone that we have. So basically, everything, every sensor node is attached to an infrastructure that is attached via a local area network. So it's a very powerful debugging facility, and we will see more of that in the later talks today. Just to give you a quick overview over the nodes that we've deployed, basically Telos B should be well known to you. Then we have something called iSense. I'm going to talk about them in the next slides very briefly. We have two different generations of iSense nodes equipped with either temperature and light sensor or passive infrared and accelerometer sensors. Then we have one specialty, I guess, that is a so-called Net10 box, which switches or converts protocols from IPv6 on the one hand side. So you have an Ethernet cable going in on the one side, 6LoWPAN communication on 802.15.4 on the other side. So you can do some IPv6 based experimentation on our testbed. And we have another sensor platform called PaceMate, which I will also show you now. So the iSense sensor node platform is produced by a spin-off from our institute. It's a modular stackable sensor node platform in which you have a core module which contains the CPU and the memory and stuff. You can plug various sensor modules depending on your application requirements. You have several modules that you can use to provide the system with energy. Depending on your application scenario, you can combine these different modules. So the iSense sensor nodes are nothing special here, just for you to have an impression. Two different generations. Core module 2 is a little bit older, has less RAM. The newer one has a little bit more RAM and a much more efficient compiler. So if you want, for example, to do IPv6 based or 6LoWPAN based experimentation, you would go for the newer module. And then you can see down below the different modules you can just stack on top with the different sensors. Telos B is very well known as well. PaceMate is something, well, now maybe even antique. It's pretty old by now. We had a project at the institute called MarathonNet, in which we equipped marathon runners with the sensor nodes. It's actually these sensor nodes, so that we could, for example, find out the positions of the runners using wireless sensor networks during a live marathon. And we use this hardware to also deploy it inside the testbed so it can be used for node level experimentation. It uses a different radio channel, so it's not 802.15.4, and well, in case somebody needs this architecture, it is still there. The deployment looks basically like this. I was referring to the wired backbone, so all the nodes are attached via USB to gateway hosts. Basically, it's the same mechanism as in place as in Guildford. And the gateway hosts itself are also attached via network to the portal server, and experimenters connect to the portal server in order to interact with the testbed. For sure, the gateway nodes are clock synchronized. It's important. And well, every gateway host has attached 3 of these boxes. In each of these boxes, you find one of the various nodes that we have. So all in all, we get this big picture. You can see all the different nodes here. If you would zoom in, you would see that this is the individual MAC addresses of the nodes, so that's our floor plan. And every room in the testbed contains 1 gateway host and 3 iSense, 3 Telos B, and 3 placement nodes. Yeah, and basically that's the Lübeck deployment. So, who's the next? Stefan?